Alright, what's up everyone? Welcome back to another video. This video is going to be on a LeetCode problem because I haven't been touching it for a while. Okay, so LeetCode, this is a medium one. I'm not even sure what's going to be the next topic or whatever. I might just go down the list on the LeetCode problems and just do it 2, 3, 4, 5, whatever. But who knows? We'll just let the future decide. Okay, so once again, I'm going to read out the problem, explain it, write out the code, explain the code, do a little quick example, and then finally explain the time and space complexity. Okay, so LeetCode problem number 2, add two numbers. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their node contains a single digit. Add the two numbers and return the sum as a linked list. Oh, excuse me. You may assume the two numbers do not contain any leading zero except the number 0 itself. Okay, so each list is a number in reverse order. So if we look at example 1 with the images, we see that list 1 has 2, 4, 3. But that means that the number is 3, 4, 2 because you want to look at it in a reverse order. So 3, 4, 2 plus 4, 6, 5 for list 2. And when you add them up, you should get the answer 807. Okay, so what we want is we want to do 342 plus 465, and that's going to give us 807. But what we're going to do, so basically what we're doing is we're going to do it in a column-wise addition. So kind of like what we do on a paper as a little kid. We're going to have this, this, and then 807, like that. And then let me add like a plus right here. This is what we're kind of doing. So column-wise addition. But because the lists are reversed, we want to see the digits in the order of ones, tens, and hundreds, right? So ones being like 2 ones, 4 tens, and 3 hundreds. And that's actually perfect because we can add from head to tail like we normally add from right to left on paper. Okay, so the algorithm idea is we want to simulate a normal addition, right? And so our idea over here is I'm going to list them out. First things first, we want to do pointers for P1 and P2. And that's going to basically go to, it's going to be pointing out list 1 and list 2. Okay. Now, number 2, we want to maintain a carry. It's going to be initially starting at 0. So the carry is, let's think about it. If you have a addition where it's like 9 plus 9, it obviously is equal to 18, but that 1 has to carry over to the tens. And then the 8 stays at 1s. So this is what I meant by carry. Number 3, we want to do a sort of like a while loop. So for each column, we want to do certain tasks. Number 1, want to do x, initial value x, or integer value x. And we're going to have the condition where if P1 is not equal to null, and then it's going to have the P1 dot value, right? Otherwise, else you want to have it as 0. Or actually, I can kind of write it like this if it looks a little bit better. So if P2 is not equal, to null, then P2 is equal to P2 dot val, and then else P2 equals 0, like that. Okay, so it's just if else statement, very simple, and I'm just gonna write it like that for now. Number 4, actually, sorry, I forgot. We still have other things to do in that while statement. In the while loop is that we want to do the sum, which is going to be x plus y plus the carry. And then we want the new digit, right? New digit is basically sum and 10. So the new digit is where we're going to move from like the ones to the tens to the hundreds and stuff like that. And then the new carry, not mu carry, but new carry is going to be equal to sum over 10, like that. I'll write out the code, explain it, and then explain the line. So don't worry. If you don't understand right now, it's fine. I'm just writing it out. That's like the idea of it. Number 4, you want to create a new node with the new digit and then add it to the result list. 5, you want to move the pointer 1 and pointer 2 forward so that they can they can basically continue if they are not null. And then finally 6, at the end, if carry is not equal to 0, then you want to add or append the final one last node with the carry, which just means 1 basically. So think about it like this. You have the digit 999 as your result, but you also have that 1 carry that you have to carry over, right? And so when that happens, if the carry is not equal to 0, then you have to make a new node and put that carry in there. And so it'll become 1000 instead, because 999 plus 1 is 1000. Okay? Yeah, okay. All right, so now let's write out the code. So we're going to have list node, and we're going to give it a dummy head. This dummy head is basically our new list node. It's going to be 0. Keep in mind, actually, I'll explain it once I've continued writing. But this is basically, the dummy head simplifies like result listing handling, kind of. List node current, and that's going to be pointing at dummy head. Now we're going to have list node pointer 1, and that's going to be on list 1. List node pointer 2, and that's going to be on list 2. We want to have integer carry, and that's going to start at 0. Now here's the while loop. If list 1 is not equal to null, or pointer 1, not list 1. If pointer 2 is also not equal to null, or carry is not equal to 0. Now here's the thing. So, and I'll write out the comment too, basically. Loop while there is a digit in either list or a remaining carry. Why is it or instead of and? Is, for example, if we look at example 3 right here, you can clearly see that list 1 has so many more nodes compared to list 2, right? And so if the while statement goes from where if P1 is not equal to null and P2 is not equal to null, then when you do something like example 3, then the while statement quickly becomes false, because we have a false here, or we have a true here, but we have a P1 being false because clearly there are more nodes and it's the pointer's not pointing at null, but P2 is pointing at null. So if this is an and, that there's a true and then a false, then the statement becomes false. So when that happens, the while loop completely just it ends basically. But that's clearly not what you want, because then that means you only did 9,999 plus 9,999. And that's not the answer. And the other reason why we have it on or for the remaining carry is because, like I mentioned previously, that if the carry also has a +1, you have to make sure that we are going to do the loop while there is a digit for either in the list P1 or P2 or a remaining carry. Maybe an example when I do the questions, it'll become clearer. But for now, let's just quickly write out. I'm going to write out like this, actually. Or I can write out the other way, too. It really is up to, I guess, how you guys wanted to look at it. But I'm trying to think if I should. Okay, let's write it out in a simple manner. It's going to hopefully it doesn't look bad. So we're going to have integer x. If P1 is not equal to null, then the x is going to become the P1.value. Else, x is going to be 0. Integer y. If P2 is not equal to null, then y equals P2.value. Else, y equals 0. Does Man, it looks kind of bad. Ooh, yikes. That does look pretty bad. It looks really ugly too. Okay, I'm gonna quickly explain it before changing it back to making it look nicer. But basically, again, it's with like example 3, right? Obviously, you can kind of see that like the P1, let's say we're on here now, and we notice that like, yes, P1 is not equal to null. So we're gonna have the X to become the P1 dot value, right? So 9. And then what we have over here is we have an integer for y where P2 is pointing at null. So this if statement is no longer true. Well, what exactly can we do? Well, instead of just skipping it or doing nothing about it, we have to plug in a 0 here. Because technically, when you read it in reverse order, and this kind of just means that we have, what is it? This is 9,999,999 plus 9,999. But what we can do, and like I said, it would look something like this in reverse order. What we can do is instead of having blanks like that and just do this, we want to have the 0 in there so that we can actually add them. So it will look something more like this. Okay, so that's why we have the else statement for that. It's because we want the y to become a 0. And this way, we can actually add them together. But clearly, when I write this out, it looks very ugly. So I'm going to quickly change this. Okay, so we're going to have integer x, where it's going to become P1 is not equal to null if, and then if it is true, then we have P1 equals to val. Otherwise, we're going to have 0. Then we're going to have integer y, where P2 is not equal to null and if that is true, then P2 becomes the value, and else it's going to be 0. Exactly like that. Now it looks so much nicer, so much cleaner. Now we write out the next one, which is going to be the sum. Sum is going to be x plus y plus the carry. Going to have integer digit, and that's going to be sum 10. So this is basically digit to store in the current node. We're going to have, we already have integer carry. So we're just going to call it carry. We're just calling it sum divided by 10. Now the carry is for the next position. Afterward, we want to have current.next, and current.next is going to become the new list node, and then it's going to have digits, and then current is going to be equal to current.next, so we can move on to the next one. So right here, let's comment, create a new node with the resulting digit. Move pointers forward if possible. And for this one, it's basically if P1 is not equal to null, then P1 is going to be P1.next. If P2 is not equal to null, then P2 is equal to P2.next. Now after all of that, we want to get out of the while loop, and then we want to return dummy head.next. Now dummy head.next is where like the actual start of the result list. So let's write it out. Dummy head.next is the actual start of the result list, like that. Perfect. Okay, now let's just run it to make sure everything is fine. Clearly, there is something not fine. Wait, what's wrong here? Am I mistaking something? Oh, that's right. Why do I even have this? There we go. Now it should work. Yes. Okay. So let me explain line by line. So what we have here is we're going to set up the variables. Dummy head is a fake head node with the value of 0. So we don't care about its value. It's just like a convenient like anchor in a way. And then we will attach all the new result nodes to the dummy head.next. And then dummy head.next, and continue on. Now the current points to the last node in the result list as we build it. So initially the result list is empty, so the current starts at dummy head, right? But then at the end, the real result list starts at like dummy head.next, and that's why I wrote this right here. Okay, so just keep that in mind. Now what we have here is like I mentioned, pointer 1 and pointer 2, and that's gonna basically walk through the list 1 and list 2. Carry is the carry from the previous digit addition. So like a normal addition on the paper, if it's a 9 plus 9, which is 18, you want to carry that 1 to the 10th place. And then add. So initially 0. Now here's the loop condition. Like I mentioned, we're going to keep looping while at least one of these is true, right? And that's why I wrote it as OR. So if P1 is not equal to null, that means list 1 still has digits left, or list 2 still has digits left, then we still continue, right? Or if the carry is not equal to 0. So even if both of the lists ended and we still have a leftover carry, then we need that last one basically. So like for example, 999 plus 1, that's going to be equal to that 1000. We're going to need that last one. And then, yeah, so basically once both pointers are null and the carry is equal to 0, then we are completely done. Okay, now here, right here. Okay, so this area basically answers like what digit do we add from list 1 and what digit do we add from list 2, right? If pointer 1 is pointing to a node, then we're going to use that node's value, which is p1.val. But if pointer 1 is null, that means we finish that list, just that list. And we're going to pretend that the digits is 0, like I mentioned before. And then it's the same with p2. So p2 for y. Again, like let's just say like you forgot, but an example would be like list 1 has 999 and then list 2 has 1, right? So after we move past the 1 for the 1 node of list 2, P2 becomes null, right? So that the y has to be 0 from then on. All right, right here, these three is where we're gonna compute the sum, digit, and carry. This is where like the normal addition logic comes in, right? Total is basically the sum is the total of digit from list 1, x, and digit from list 2, y, and then plus previous carry. But so for example, in the ones place, carry is gonna be 0. So you don't have to worry about that. It would just be x plus y plus 0. But then if the x plus y, I'll show this part obviously. Okay, so quick example, it would be something like we have 9 plus 8 plus 1, right? That's gonna be equal to 18. Like I said, the 9 is x, 8 is y, carry is 1. So afterward, digit is the ones place of sum. So it would look something like 18 and then 10, and that's going to give you the remainder, which is 8. And that's where we're going to store in the new node, right? Carry is the tens place of sum. So when that happens, you want to do it basically does what exactly it does, right? So you have 18 divided by 10 instead, and that's going to give you 1. So that carry is going to give you either a 1 or 0. So it's an integer division basically. And that carry will be added into the next column to the left. Hopefully that makes sense. I'll go do the example, don't worry. Next, we want to create the new node and link it. So that's why we have the new linked list digit. It creates a new node holding the current digit of the result. And then current.next is basically, it's going to attaches this new node after the current one. Afterward, we want to basically move the input pointer forward. So if pointer 1 is not equal to null, move it to the next one. Next node in list 2. If pointer 2 is not equal to null, then move to the next node in list 2. And then return result is basically the dummy.next. Because remember, dummy head was a fake node. The actual result list starts at the next node after it. All right, so let's do a very, very, very easy example. Yeah, we're gonna have, for example, this one, and that's gonna be equal to 9, pointing at 9, pointing at 9. So that is basically 999. Then we have 2, and that's just gonna give you 1, right? So 1. Yeah. Okay, so initial state, pointer 1 or P1 is pointing at 9, and pointer 2 is at 1. Carry is still 0. And so right now the result is empty because it's just a dummy head. So now we want to go through the first iteration, which is 1. So P1 points at 9, P2 points at 1. We want to get X. And X is going to be, if P1 is not equal to null, then we're going to have the value, right? So X is pointing at a node, is not null, so the value is 9. And then we're going to have Y, which is the same thing, but it's 1 this time. So when we get that, now we want to do the sum. The sum is basically X plus Y plus carry, which is 9 plus 1 plus 0, carry being the 0, and then that's going to be equal to 10. Now we get the digit. Digit is basically sum, and it's going to be 10. So when that happens, it's 10 and then 10, so that will give you 0. And then the carry will be equal to sum divided by 10, like that. So 10 over 10, and that's going to give you 1. 10 divided by 10 is 1. Now we're going to create the node. So current.next is going to be equal to the new list. And so now it will look something, the result list will look something like this. We have dummy head, and it's going to point at 0. Yeah, don't forget, I wrote digits. The new node, the new list node is going to be digit, not carry, not sum. It's digit, and digit is what we see as 0. So current is now going to point to that 0 node, and then now we're going to move the pointer to the next one, which is 9 over here, which is the second one, and P2.next is pointing at null, right? Because list 2 only has 1 node. And now the loop condition obviously is still true because the P1 is not equal to null, right? Even though P2 now is equal to null, this is an or, not an and. So it is true, we continue. Now we're going to do iteration number 2. Now iteration number 2 is the same thing. We're going to look at, so P1 now is 9 for the second, but P2 is null now. Don't forget, our carry is currently now 1 due to what we get from here. Now, let's get the X and Y. Once again, X is 9, but this time because Y is pointing at null, so this part is no longer true. So we don't get the P2 value, instead we get 0. So now what we have here is, for the sum, it'll be 9 plus 0, but plus 1 for the carry, because the carry is 1. So once again, we get 10. And if you do the digits and the carry, it gives you the same thing. And so now we create the new node, another node, which is going to be 0. When you do the iteration 3, again, it's the same thing. And so when that happens, you create another 0. Now for the iteration 4 is where both lists ends, right? But the carry, so now we finish the 9 over here as well. So list 1 and list 2 are both now at null. So these two are basically false. But the carry has a 1 actually. So this is still true. When that happens, we're going to go through the list one more time. But this time, the X is 0 and the Y is 0. So now for the sum, what we have here is 0 plus 1, which gives you 1. And when you do 1 and then 10, it gives you the number 1. What about 1 divided by 10? That's a 0. So when that happens, the carry is now 0, but the digit's 1. So we're going to have to plug that digit 1 in. Like that. And now the loop ends. Because both lists are now pointing at null, and the carry is now equal to 0. So when that happens, the loop condition fails. And so we exit. And then we return basically this. But dummy.next. So we're gonna basically forget about this dummy head. And so when we print out the result, we will get 0001, which represents the number 1000 in a reverse order. And when that happens, the list is correct. Dang, I talked too long. Okay, yeah, I talked way too long. But, it is what it is. Just submit it. Yeah, I got it correct. Awesome. Okay, so, and then finally, I'll just basically talk about the time and space complexity. So, here's the thing. Because we have 2 lengths for lists, we have 2 lists, right? We have the list 1 and list 2. And if we look at example 3, the list 1 and list 2 has different lengths. So what we want to do is we want to let n be equal to the length of list 1, and then m equals the length of list 2. And then let's just give it a random, call it L, and that's going to be the whichever list is the biggest. So that's why we have max. So again, looking at example 3, the length of list 1 is clearly bigger, so L would become like n. L is going to be equal to n, right? And because we visit each node for each list once, the time will be, the time would just be big O of L. And that L just shows like whichever list is the longest, because we do have to, constant time work per position. So add, modulo, and divide, and like create node. And so, oh yeah, by the way, it can also be L plus 1, because the result list has at most L plus 1 nodes, like if there is a carry at the end, right? So that basically increases the length by like another 1. So this plus 1 is if there is a carry at the end. Now, for space, there is extra space. We created a new list for the result, so the output is required, because the output is required, right? And aside from that, only a few variable like pointers and carry, and that's it. So when it comes to space, there's nothing really much to talk about besides big O of 1, and that's it. And so, yeah, that's pretty much it for the video. I kind of already explained it, submitted everything, so it should be fine. Yeah, thanks for watching. Thanks.